And you also have. Oh.
Sorry, I forgot.
Oh, okay. We were on mute. Okay, let's begin again. No, just just yeah, changes in const-expr functions. And your vector and strings are also const-expr for now in C++20. Okay, so now let's go to a new keyword. You know, who has written this keyword in their code? You know? Oh, dang. Okay. So yeah, you know this better than me, but hopefully all the rest of the room will learn something new today. Let's see. Okay, so the thing is, let's do a reminder about const-expr, okay, before we get into const-eval. The const-expr keyword is actually like an indication to the compiler. It's not really an obligation. What do I mean? You're kind of telling the compiler, hey compiler, please, you know, if you can, do this during compilation time, right? But if it cannot, it will do it during runtime, and will do it silently. So for instance, if you have this function, oh, it's a little small, isn't it? Well, it's just a function that is adding two integers. You know, I'm sure you've seen functions more complex than that, and it's const-expr with the little syntax trailing there. So for instance here, I have two constants, and I'm calling this function with these two constants, and it's going to be executed at compile time, which is nice. We like that. However, if one of the variables is not a const, it's going to be executed at runtime, and there's nothing you can do about it. What if there was a keyword that could, you know, force the compiler to do it during compilation, or else compilation failure? That's const-eval. And the technical term for that is immediate function. So if you want to define an immediate function, we get the same example. We just replace const-expr by const-eval, and now you get a compilation error. So there's it's a different way to express, you know, a stricter requirement for the compiler. And that's the last keyword related to const. It's const init. Const init, it's actually pretty simple, right? Although it has const in the name, it's talking about the thing, right, the right-hand side, the thing that's initializing your variable. The thing that's initializing your variable must be known during compilation time, must be a constant expression. If it's not, you're going to get a compilation error. It's as simple as that, you know. And why would we do this? This is again to help with undefined behavior. In C++, we have something that's known the static initialization fiasco, in which if you initialize a static variable with something that's dynamic, you can have problems. You don't know which one gets initialized first. You get undefined behavior. And with this, you know, you are preventing this by getting a compilation error instead of undefined behavior. And that's also something we like. And it does not imply const, of course. As you can see here, you have the answer. You're initializing it with a constant expression, and then you're modifying it to 42. And now it's the end. Yeah, it was very brief, you know. It was my first presentation in front of you. Hopefully, you know, you learned something new. And yeah, if you have any questions. All right. No questions then? Okay. Oh, we have a question.
You showed that we can use an exception in the context. Do you know that there is a lot of people who are writing code who are compiling without exception? Do you know if we can still use exception in no except context, in a context context, even when the no except flag is set or is there a way?
Oh. Okay, that's a great question. I've never used that flag, you know, personally. I don't know. Does anyone know, actually? Oh, can you repeat the question? Yeah, the question is with what if your compilation has no exceptions enabled, right? And how does that work with exceptions within const-expr context? Right, I'm not entirely sure. Has anyone ever tried this?
The language does not say anything about it because it's not compliant with the language to disable exceptions. So there is no answer possible at the level of the C++ language. There might be different answers for different compilers, and I don't know which they are.
It's like implementation defined then? In a way?
No, it's not. It's not even an implementation defined. The standard says you should be able to throw an exception. It's not. Exceptions are not optional in the standard.
Oh, okay. Okay. Yeah. And just to be quite clear, right, you cannot throw the exception from here, right? You need to catch it inside. Everything needs to remain inside.
Or you can throw it. It can be interesting to throw it and not catch it, which allows you to trigger an error at compile time.
Yeah, there you go. That's smart. Hey, any more questions? Did I respect the time? I did? Okay. Hey, thank you.
Thank you.
I'll get that back.
Someone else. As always, you're always welcome. Yes, nice graph. So at my company, we are sometimes building the code that we write. And for that, we're using CMake and with many different configurations. And I discovered something interesting that I would like to share. So I'm working on Windows. And on Windows, there are basically many more, but two main ways to build with CMake. One is to use Ninja and one is to use MSVC. And so when I say using Ninja, we could use Ninja with any compilers, but we are using Ninja with the Visual Studio compiler, with cl.exe. So if you use CMake to build with Ninja, or if you use CMake to build with MSBuild, in the perfect world, the compilation time would be the same because it's the same compiler that is executed. So I just build with Ninja, and I run CMake -build, and then just did the same with MSBuild. And no, sorry, it was not that much longer because you see it just reaches the end of the screen. The real one is this one. So yeah, basically from 200 seconds to 1,400 seconds, something like that, 7 times slower. And so it was to build the Z3. It's an open source library. Yeah, and why? So I wonder why. And I also discovered that while I was building with Ninja, my computer was very unresponsive. And while I was building with MSBuild, my computer was very responsive. So kudos to MSBuild. But it was a little bit unfair because by default, Ninja is building in parallel. MSBuild is not. So let's try to force it with CMake -build to build in parallel. There are two ways to do it. Sorry for the font size, which is very small, but one is I run CMake -build -j, which says to CMake to build in parallel. And I run with CMake -build -m. So -- say, okay, no, CMake don't interpret those arguments, pass those arguments to the actual stuff. And -m is telling MSBuild to parallelize. And as you can see, the result is much better than just CMake -build, which is okay, but it's still much work than Ninja. Could we do better? Well, yes. Instead of using CMake -build, I just use MSBuild on the generated project. And then we get a time which is still longer than Ninja, but it's in the same order of magnitude. So why? I don't know. I'm not sure. I have some hypotheses. From what I looked in the log, it seemed that when I run CMake -build, it kind of run one MSBuild for each project, while when I do MSBuild, I pass to MSBuild the solution, which is the group of projects, so it has more opportunities to parallelize different stuff. He sees more of the code at one time, so he has the opportunity to parallelize much more. And when I look at the processor on my computer, yes, they were getting more busy with that part. I'm not sure it's the only reason, but just if you have the same kind of issue and you really want to use the MSBuild, because there are some good points about using MSBuild, especially if you want to work interactively in Visual Studio. You can do it directly from the CMake file, but it's not the same as if you work on an actual MSBuild project. So if you want to compile an actual MSBuild project from CMake, CMake -build might not be the right option. That's all. Yeah, question?
Yes, MSBuild is forking itself with internal heuristic. So clearly, may fork for per project, but also globally.
Yeah.
That's probably one of.
I guess that's what happened. Yeah.
Yeah, and it's also it also may work through the dependency graph differently. There are in MSBuild there are two flags, one graph and isolate, with theoretically help you to optimize this kind of stuff, because mainly when you pass a solution to MSBuild, it's you are passing as if you are multiple projects. There is no real solution for MSBuild, so dependency are resolved step by step for every project. With graph and isolate, theoretically, it's resolved one at solution level, and after it's compiled.
Okay.
So there may be various.
Yeah, there may be ways to tune it even better, probably. Yeah. But just by default, it's already a huge difference.
Yeah, yeah. There are lots of heuristic present in MSBuild.
Other comments or questions?
I had exactly the same behavior, but we also use another tools that parallelize the compilation between multiple nodes called inclusively. It's awful. It's very awful. So we switched to Ninja, and for myself, I switched to Vim to code. So nice, working well.
I tried Incredibuild once, and maybe the infrastructure was not great, but it took so much time to send code to the other nodes that it was faster to build locally. Yeah. But maybe if you have very fast network, I don't know, maybe it could still be profitable, depending also on the way your code is organized, probably.
You can gain the time with Incredibuild if you have very separated project, not a lot of dependencies. It will be more fast than if you build one solution.
We switched to MSVC 2022, and with this version, impossible to build parallelly so we dropped these tools, and now it's working much.
Yeah.
What would be the reason to use MSBuild?
So, if you like the Visual Studio IDE, there are two ways in the IDE to work on a project. You can work directly on CMake, and you can work on MSBuild. But it's the way the projects are presented in the IDE is different. Like if you work directly on the folder with CMake, basically the layout of the project is the layout of your directories on the drive. While if you are working on a MSBuild project, they can be organized in folders which are not drive folders, and so it's a view that could be nicer. You can even if, for example, you could have 10,000 files in one folder, but they could be presented in several groups in the IDE. Also, what I like is that you can view properties on the individual files if you work with MSBuild, which to me is a way to see what CMake did. Like you have very complex CMake that create many compile options for specific files and so on, and you want to know what is the outcome of it. If you generate a MSBuild project, you can just right-click, see the actual properties that were resolved from CMake. While if you work directly on CMake, you see the source of the CMake, but you don't see the result. It's kind of an intermediate execution between the CMake and the actual build somehow. So and there are also small differences, like the configuration are not the same. So the UI is different, and when you're all like me and you worked for so many years in one way, it's very tough to change. Lots of very small changes that are making your life hell. Oh, he went away? What should I do? Should I dance or?
Do you have a good joke?
Did you compare with Ninja, but not in parallel, dash G1, for example?
No, I didn't try that. my goal was not just to make a benchmark, but was to actually build some code. So when I saw that, I didn't want to slow down Ninja. I wanted to speed up MSBuild. So no, I didn't try it. I guess it should be around the same, but I'm not sure.
For MSBuild, I didn't know, but in comparison of Ninja and classic Unix makefile, Ninja command run so much faster in my experience.
And any kind of explanation why?
Shorter command, maybe better than
in Ninja, it's every command line is written in the Ninja file, where in Makefile you need to parse and regex.
Okay, so not the compilation part itself, but the Ninja, the overhead of the build system is almost zero with Ninja. Yeah. And that actually comes back to another point of why MSBuild might be better. I don't know if it's still true, but in the past when I tried it, because I did try to move to the directly using CMake on Visual Studio, and there was one point when it was slower. It's when you have almost nothing to build. The startup time when you have a Visual Studio project in Visual Studio, the startup time of a build is very fast. I guess it has lots of stuff in memory. While when you go through Ninja with a CMake file, the startup time is a little bit longer. So if you have lots of stuff to build, it's not a big deal, because what you lose on one side you gain on the other side. But when you have just do a small change which does not impact anything, just one file and everything compiles, it was significantly, not significant, but visibly faster with MSBuild than with CMake list when I tried it on my code base.
Ninja is considered the fastest in Europe. There are nothing to do, it's the fastest. It's benchmark as the fastest.
Yeah, but how do you build? I'm not talking on the command line. I'm already talking from the IDE. And from the IDE, I guess that MSBuild has some stuff that it keeps in memory. It doesn't have to read any file when you run the build. Anyways, I don't know why, but and I don't know if it's still the case right now, but at that time it was my experience.
I think what you are benchmarking is not Ninja directly, it's Ninja over CMake over the CEO.
Maybe the comparison is unfair. I'm just talking about my end user feeling without trying to understand more.
Usually when you go this way, I use the studio in a way that it's just a makefile project. The studio does not parse anything. I remove all the project definitions. I use the studio as an IDE text editor, enriched, and call the command line in Ninja directly.
And if you do that, so if you directly call Ninja, you are losing some of why you could use Visual Studio. I mean, if you do that, you could use a VS Code, and that's why you switch to VS Code. But if you're used to the bells and whistles of Visual Studio, like good completions and this kind of stuff, it's
profiling VS Code by default has no good profiler.
Yeah, but I think maybe for profiler, it's working without having an actual project might not be an issue. It could just launch the profiler out of line, but there are some stuff for which not having a project, you will not have the same experience in Visual Studio. And you may not want this experience, which is fine. I mean, I'm really all in favor of everybody does what he wants on this topic. Because it's a tool you're going to work with 8 hours a day, and if somebody forces you to use it in a way that makes it painful, it's the worst. Well, I thought it would be faster, but many questions, so
Thank you.
thanks.